Combustion, flame and fuels. Learning objectives. Combustion and ignition temperature. Flames. Fuels and their types. Classification of fuels. Pollution caused by fuels. Combustion and ignition temperature. A large number of materials burn in the presence of air or oxygen with the release of heat and light. Burning of a substance is called combustion. The materials which burn easily are called the combustible materials. Combustion is sustained by the presence of either pure oxygen or oxygen in air. Oxygen is a supporter of combustion. Without it, no combustion or burning will take place and is therefore the supporter of combustion. Combustion is an exothermic process, and the reaction products of this type of chemical reaction are carbon dioxide and water. 1. Types of combustion of coal. C plus O2, CO2 plus heat, coal, carbon dioxide. A. Spontaneous combustion, when substance does not need external heat, energy to start the combustion. The process is called spontaneous combustion. For example, when white phosphorus is kept in air for some time, it will automatically catch fire. The phosphorus reacts with air to form oxide, which is an exothermic reaction. The heat generated by the formation of the oxide ignites the rest of the white phosphorus. White phosphorus combustion. B. Rapid combustion. Rapid combustion occurs when a large amount of heat is released in a very short time. Example of rapid combustion can be cited in case of bombs. Lighting up of LPG in the kitchen, which produces heat and light immediately, is also an example of spontaneous combustion. LPG gas 2. Combustible material. A substance which on heating burns with release of heat and light energy is called a combustible material. The reaction below show the effects of burning methane in air. CH4 plus 2O2, CO2 plus 2H2O plus heat, methane, oxygen, carbon dioxide, water. Examples of combustible substances: wood, coal, paper, petrol, diesel, wax, alcohol, liquefied petroleum gas, LPG, etc. are examples of combustible substances. 3. Supporters of combustion. A substance which helps in the combustion of a combustible material is known as supporter of combustion. Examples of supporters of combustion: oxygen and air are supporters of combustion. The sure way to put a fire would be to smother the flame and cut off the oxygen. This prevents the oxygen to reach the fire and fire dies out. For fire to burn easily, you have seen that air has to be blown around the wood or coal. This provides oxygen for fire to burn easily. Air contains 21% oxygen and 78% nitrogen, which is not supportive for combustion. The substances that burn slowly in the air burn faster in pure oxygen as they get more oxygen for burning. 4. Ignition temperature. Ignition temperature or ignition point is the minimum temperature at which the substance catches fire. Below the ignition temperature, even if a combustible substance is present along with oxygen, the fire will not start. Therefore, a substance has to be heated to its ignition temperature before it starts burning. Example: the ignition temperature of white phosphorus is 35 degrees Celsius during summer. Ordinary room temperature can rise to about 35 degrees Celsius, and thus white phosphorus gets ignited spontaneously. This is the same reason that water is used to put out ordinary fire, because water reduces the temperature of the substance that has caught fire below its ignition point. Ignition temperature. 5. Inflammable substances. The substances which have low ignition temperature, generally lower than 100 degrees Celsius, are called inflammable substances. The vapor of these substances catches fire even if here is a minor spark. Examples of inflammable substances are petrol, LPG, alcohol, ether, benzene, etc. petrol, LPG, alcohol. To prove that the supporters of combustion are necessary for combustion. A. When we use fire extinguisher on fire, the foam from the fire extinguisher covers the fire and cuts off the oxygen supply to the fire and fire extinguishes. B. Have you noticed bucket of sand placed in different place for firefighting? Why? When we pour sand over the fire, it cut off its air supply and without oxygen fire dies out. C. If any cloth catches fire, we immediately cover the cloth with thick blanket as the thick blanket cuts off the air supply to the fire and the fire is put off. To prove that the ignition temperature is necessary for combustion. A. Take water in a paper cup and heat the base of the cup over a candle. The paper will not catch fire, but the water will heat up. This is because the water keeps the temperature of the paper lower than its ignition point. B. If we pour water over burning woods, fire dies out because water reduces the temperature of the burning woods that has caught fire below its ignition point. Consequently, fire dies out. Conditions required for combustion. As discussed above, there are mainly 3 requirements for the combustion to start. Presence of a combustible substance. Continuous supply of supporters of combustion. Ignition temperature, i.e., the temperature of the combustible temperature should be above ignition temperature. Incomplete combustion, an environmental hazard. As we know, most of the fuels are essentially carbon-based fuels which contain a large percentage of carbon. If these fuels are subjected to incomplete combustion, it may give rise to the following problems. 1. During incomplete combustion, when carbon-based fuels are burned, carbon monoxide is formed. Carbon monoxide is a very poisonous gas and can cause respiratory problem, which may lead to death also. 2. Incomplete combustion of carbon-based fuels leads to more of smoke, which again creates respiratory problems. A part of the unburnt carbon goes to the atmosphere as soon, which has become a major health problem in big industrial cities. Smoke from incomplete combustion. Flames. What have you noticed in most fires? Well, very obviously, the flame. A flame is region where combustion of fuel takes place. Have you noticed that flame has different colors? The color of the flame depends on the temperature of the flame, the substance that is burning. In case of hydrocarbons, the flame is either blue or yellow. Blue flame. A blue flame is a non-luminous flame and occurs because of complete burning of hydrocarbons in the fuel. A blue flame is clean and does not leave any residue or any other. A blue flame is given out when the oxygen supply is plentiful while the process of burning occurs. Yellow flame. A yellow flame comes about when there is insufficient supply of oxygen. It is a luminous, i.e., light-giving flame. In this case, the hydrocarbons do not burn completely. The temperature of the flame is lower than that of the blue flame. The yellow flame also leaves behind a black soot or residue. Candle flame. A candle is made of wax made from petrochemicals. The wick is lighted, wax gets evaporated and catches fire. As the vapors rise higher, they stay longer in the hot regions of the flame and start burning completely with oxygen. Blue flame of hydrocarbon. Yellow flame of burning wood. Candle flame. The candle flame has 4 parts. A. Blue zone. Near the base of the flame, the air mixes with the wax vapors arising from the molten wax and a part of this vapor burns completely, giving rise to blue color high heat flame. B. In a dark zone, the region closest to the wick is dark in color because air cannot reach that region, so the gases are not burning. This zone consists of unburnt wax vapors given by the molten wax. This zone is slightly dark because a part of the wax vapor decomposes to carbon particles. The presence of wax vapor in this area can be shown by the following experiment. Activity 5.1. Aim. to show the presence of wax vapor in the dark zone. Material required: a candle, glass tubing and matchbox. Method: fix a candle on a table and light the candle. When the flame of the candle is absolutely steady, introduce a glass tubing in the dark zone of the flame. You will notice that a grayish-white vapor starts filling the glass tubing from the dark zone and subsequently coming out of the other end. Now bring a lighted matchstick near the other end of the glass tubing from where this vapor is coming out. You will notice that the vapor catches fire and start burning with flame similar to the candle flame. Conclusion: these vapors are of wax, which are produced from the molten wax because of the heat. C. Luminous zone. In this zone, the partial combustion of wax vapors takes place with the release of heat energy. The heat energy so produced decomposes the wax vapors into carbon particles. The carbon particles, when get very hot, they emit yellow light. This zone is hotter than the dark zone but colder than the non-luminous zone. The red area near the center of the flame is about 800 degrees Celsius. The outer orange and yellow areas are hotter than this region. The presence of the unburnt carbon particles can be shown by the following experiment. Activity 5.2. Aim: to prove that the luminous zone of the candle flame contains unburnt carbon particles. Material required: a candle, glass slide, fire tongs and matchbox. Method: fix a candle on a table and light the candle. When the flame of the candle is absolutely steady, introduce a glass slide into the luminous part of the flame with the help of fire tongs. Hold the slide in this position for about half a minute and remove the glass slide. You will notice a circular gray-black ring formed on the glass slide. You will also notice that there is no deposit in the center of the ring. Conclusion: the black color is due to the deposition of the carbon particles from the luminous zone of the flame. The center of the ring does not have any carbon particles because this part was over the dark zone, which does not have any unburnt carbon particles. D. Non-luminous zone. This region, the outer rim of the flame, is practically colorless, a very faint blue, and is the hottest part of the candle flame. In this zone, the complete combustion of wax vapors and carbon particles occurs. The air from the sides of the flame mixes with the wax vapors and carbon particles and burns them completely and produces carbon dioxide and water. Fuels and their types. Fuels are those substances that, when oxidized, give rise to heat energy. This heat energy can be converted to other forms of energy like electricity or mechanical energy like vehicle motion. Almost all activities we perform for our day-to-day activity use fuel in some form. The food we consume can be termed as fuel, as it is converted in our body to give us energy to sustain, breathe, walk, have our hearts beating, brains functioning. Thus, fuels form a very basic and important component in our lives. Fuels: any substance which is easily available and burns in air at moderate rate with production of large amount of energy without leaving behind any or minimum undesirable and harmful residue is called a fuel. Calorific value of fuels: the amount of energy generated when 1 unit mass of fuel, for example, 1 kilogram, is burnt completely is known as the calorific value of the fuel. The heat generated by fuels when they burn in joules or calories measures quality of fuels. All fuels do not burn efficiently. Thus, there are fuels that produce more heat than the others are. The calorific value of the fuels is expressed in kilojoules per kilogram, kilojoules/kg. The table below gives the calorific values of some of the common fuels used for domestic and industrial use. Type of fuel. Fuel. Calorific value, kilojoules/kg. Solid. Charcoal, 33,000. Coal, 25,330. Wood, 17,000 to 20,000. Liquid. Kerosene, 47,000. Petrol, 50,000. Diesel, 45,000. Gaseous, biogas, 35,000 to 40,000. Butane, LPG, 55,000. Methane, 55,000. Characteristics of an ideal fuel. As we know, there are quite a few substances like petrol, diesel to methane gas and synthetic fuels which are being used as fuels depending upon cost, easy availability and its efficiency. There are a number of criteria which may be checked listed before choosing a fuel for its application. The criteria for an ideal fuel are as follows. A. High calorific value. The fuel should have high calorific value. A fuel that gives more calories per unit of weight is a better choice. B. Moderate rate of combustion. The fuel should have a moderate rate of combustion. The burning of the fuel should release heat in a controlled manner so that the fire neither dies nor explodes. C. Low ignition temperature. The fuel should have a suitable ignition temperature. If the ignition temperature is too low, then the fuel is not suitable as it will cause fire easily. If the ignition temperature is too high, then again it is not suitable, as reaching the ignition temperature will not be practical. D. Low level of pollution. The fuel should have low content of non-combustible materials or impurities. When heated, these impurities may cause pollution and give out undesirable harmful gases. Thus, an ideal fuel should not pollute the air by emanating harmful gases. E. Easily available and cheap. The fuel should be easily available and cost-effective. Some fuels have all the characteristics of an ideal fuel like high calorific value, low pollution-causing gases, like high-octane petrol, but the cost of this fuel is very high and is not readily available at petrol filling stations. F. Easy to store and transport. The fuel should be easy to store and transport. G. Unique use as fuel. The fuel should not be more useful for other purposes other than its use as fuel. For example, wood is a fuel but that denudes forest cover and is environmentally harmful to fell trees. Hence it is not a suitable or ideal fuel. Classification of fuels. Fuels can be classified as solid, liquid and gaseous fuels. Solid fuels. The fuels which occur in solid state in room temperature are called solid fuels. Examples of solid fuels are wood, coal, charcoal. Coal is usually referred to as black diamond. Solid fuels. Wood, coal, diesel, kerosene. Liquid fuels. The fuels which occur in liquid state at room temperature are called the liquid fuels. Examples of liquid fuels are petrol, kerosene, diesel, alcohol, liquid hydrogen. Petroleum is called as black gold. Gaseous fuels. The fuels which occur in gaseous state at room temperature are called the gaseous fuels. Examples: naturally occurring gaseous fuels are methane, liquid petroleum gas, butane, hydrogen. Artificially prepared fuels gases are coal gas, oil gas, gobar gas, petrol gas, water gas. Fossil fuels. The natural fuels formed from the remains of organisms buried under the earth long, long ago, are called fossil fuels. Examples: coal, petroleum and natural gas. Fossil fuels are exhaustible natural resources because once all the fossil fuels are used up, they will be gone forever. Fuels can also be divided into categories such as primary and secondary fuels. Primary fuels. Fuels that directly produce heat on ignition are called primary type of fuels. They occur in nature as natural products without involvement of any artificial processing. Examples are wood, coal, petroleum, natural gas, animal dung, etc. Secondary fuels. Fuels that are processed and prepared from raw or primary fuels are called secondary type of fuels. Examples are charcoal, coke, petrol, diesel, kerosene, coal gas, gobar gas, water gas. The best fuel, gaseous fuels. Fuels in all the three states, i.e. solid, liquid and gaseous, are being used by us, but gaseous fuels are considered as the best as fuels. The reasons for this are as follows. A. Easy transportation. Gaseous fuels can be transported with ease through cylinders and pipelines. For example, our cooking gas comes in cylinders. B. Less solid residue. Gaseous fuels do not leave behind solid residue like ash on combustion, thus lesser chances of environment pollution. C. Less harmful gaseous substances. The percentage of release of harmful gaseous substances on combustion is much lesser in comparison to other form of fuels. D. Easy availability and cheap. Gaseous fuels are easily available and much cheaper in comparison to other fuels. E. Low ignition temperature. The gaseous fuels have low ignition temperature and hence are easy to start the combustion by even a small spark. No waiting time or elaborate requirement for combustion. F. High calorific value. The gaseous fuels have higher calorific value as compared to solid or liquid fuels. G. Control of combustion. Rate of combustion of gaseous fuels can be very easily controlled by using controlling valve devices. H. Clean handling. Gaseous fuels are much cleaner to handle in household as well as in industries. For example, cooking gas is a much cleaner way of cooking food in comparison to coal. Judicious uses of fuels. The most of the fuels which we use are fossil fuels. Fossil fuels are the lifeblood of our society and for many others around the world. Over 85% of our energy demands are met by the combustion of fossil fuels. Fossil fuels, coal, oil and natural gas, are a non-renewable source of energy. Formed from plants and animals that lived up to 300 million years ago, fossil fuels are found in deposits beneath the earth. In the earlier days of Earth, the plants and animals that lived, then eventually died and decomposed in conditions of high temperature. These fuels are burned to release the chemical energy that is stored within this resource. All these fossil fuels are limited in quantity. The energy expert says that if we continue to use them at the present rate, they are not going to last for more than 50 years. So, the use of lesser fossil fuels will lead to cleaner environment and smaller risk of global warming. A judicious use of the available fossil fuels is an absolute necessity. We should use energy in any form for the essentially required purposes. Avoiding misuse of energy should be a main part of future energy plans. We should also develop other sources of energy. In addition to the fossil fuel, wind, solar energy, tidal energy, geothermal energy and energy of flowing water are being used for generating renewable energy. We must further develop these renewable energy sources for future generation. With these options we can help to phase out our dependency on fossil fuels and find clean, efficient sources of power. Pollution caused by fuels. In addition to these two main products, in certain conditions, some more products are also released in combustion of fuels like sulfur dioxide, carbon monoxide, carbon or soot particles. The byproducts, when mixed with air, change the composition of air that we breathe in. This polluted air may result in many harmful effects to human beings and the environment. This imbalance caused in the atmospheric proportion of gases by burning of fuels is known as pollution. Let us discuss the main pollutants and their effect on environment as well as our life in some more details. Pollution caused by burning coal. Coal is one of the main fuels to provide energy for electricity generation, for industries, for households, etc. Coal contains chemicals like carbon, hydrogen, oxygen, sulfur and nitrogen. When coal burns we get carbon dioxide, carbon monoxide, sulfur dioxide and smoke. Smoke by burning coal. Carbon dioxide. When coal burns with sufficient supply of oxygen, then carbon dioxide or CO2 is a byproduct. CO2 is a pollutant, and excess of this gas traps sun's heat energy, thereby increasing the atmospheric temperature. This is the reason CO2 is called a greenhouse gas, because this is exactly what happens in glass house where plants are grown. Carbon monoxide. When coal burns with insufficient supply of oxygen, the carbon monoxide or CO is formed. CO is a poisonous gas, and when it is inhaled, it creates respiratory problems, suffocation due to inadequate supply of oxygen in the blood, etc. Excess levels of CO may even cause death. Sulfur dioxide. Sulfur dioxide or SO2 is produced during the burning of the coal. When this gas mixes with air and moisture in the air, it forms sulfuric acid. This acid may combine with rain and is called acid rain. The acid rain is corrosive and harmful to plants, crops, human beings and animal. For example, the world-famous Taj Mahal is turning yellowish because of this type of pollution caused by a refinery in its close proximity. Nitrogen oxide. Like sulfur dioxide, NO2 also react with water vapor present in the air, and then in the presence of sunlight gets converted to nitric acid. During rain, this acid gets dissolved in the rain and damages plants, buildings and affects us also. Smoke. Carbon particles and ash. Carbon component that is not converted into either CO2 or CO goes into the atmosphere as black smoke containing unburned carbon particles and ash suspended in the air. In winter months, this pollution of solid suspended particles with smoke causes smog, which causes major respiratory problem in humans. It is harmful to inhale smoke, as it will cause suffocation. Also, the black smoke blackens clothes, buildings, etc. Vehicular pollution caused by burning petroleum-based products. Vehicles run on diesel or petrol. These petroleum products contain hydrocarbons along with lead chemicals. Lead chemicals are added to make these fuels heavy and avoid knocking in vehicles. When these petroleum products burn, they emit unburned hydrocarbons, unburned carbon particles, some alcohols and acids and lead compounds. The engine exhaust throws unburned hydrocarbons, carbon particles, carbon monoxide along with some organic alcohols and acids in the air. The lead compound tetrethyl lead, PbC2H5, added to petrol to slow down its rate of combustion, is also a very high-risk pollutant. Thus the engine exhausts give off gases which are highly polluting and harmful components in the atmosphere. Keywords. Combustible. Substances that catch fire rapidly. Ignition point. Temperature at which a substance begins to burn. Fuel. Any substance which is easily available and burns in air at moderate rate. LPG. Liquefied petroleum gas. Summary. A large number of materials burn in the presence of air or oxygen with the release of heat and light. Burning of a substance is called combustion. The chemical process in which a substance burns in the presence of air or oxygen to produce heat and light is called the combustion. A substance which on heating burns with release of heat and light energy is called a combustible material. The color of the flame depends on the temperature of the flame, the substance that is burning. In luminous zone, the partial combustion of wax vapors takes place with the release of heat energy. This region, the outer rim of the flame, is practically colorless, a very faint blue, and is the hottest part of the candle flame. Fuels in all the three states, i.e. solid, liquid and gaseous, are being used by us, but gaseous fuels are considered as the best of fuels. Fossil fuels, coal, oil and natural gas, are a non-renewable source of energy. The imbalance caused in the atmospheric proportion of gases by burning of fuels is known as pollution. Coal is one of the main fuels to provide energy for electricity generation, for industries, for households, etc. Sulfur dioxide or SO2 is produced during the burning of the coal. Vehicles run on diesel or petrol. These petroleum products contain hydrocarbons along with lead chemicals.